engineer, that is a communication channel, because communication channel is random in nature. This randomness which is introduced by communication channel is where this communication research problem starts. If though there is no randomness in the channel, then there is no challenge in the communication. So in other words, one of the major challenge in communication is the randomness. Now, what type of randomness it introduces? So channel is not linear. It is non-linear. Non-linear means it is not behaving in the similar way for all the amplitude, all the phase, all the frequency. That is non-linearity. And not only this, channel is causing system to be asynchronous. It is introducing non-linear delay into the system. For one bit, it is introducing one delay. For other bit, it is introducing other delay. For one user, delay is different. For other user, delay is different. So this non-linearity is a major issue, and this is where and wherever there is a issue for researcher, there is a avenue. Whenever there is a issue, wherever there is a problem, there is a avenue for the researcher, there is a avenue for the scientist, and this is where the avenue for the researcher who are working in communication, especially at the physical layer, starts. And the signal which is basically retrieved or which comes out of the channel is given to the receiver, which actually is just opposite to, in layman language, it is just opposite to the transmitter side. So we have a modulator, we have a demodulator. D means removal. So you are removing the modulation. So whatever modulation you have done is removed using demodulator. Why we want to do this? Because my major interest is this information source. Whatever, because initially what we have said is what is effective communication. Whatever I have transmitted, I must receive that. What I have transmitted is the information. This information may be voice, it may be your telemedicine data, or some other source of information may be there. I want to get the same thing at the end user. So for that, I need to do opposite process, whatever I have done at the whatever I have done at the transmitter side. So if I have done modulation, I have to demodulate. I have done encoding, I have to decode. And there is a information source. There is a source. There has to be a sink. So for example, right now I am a source and you people are the sink. When you will speak, you will be a source, I will be a sink. So this is the end user. Okay. So if so this is what is the element of communication. If you look into mobile communication, you will find these elements either in one way or other. If you look into internet communication, if you link to satellite communication, if you link into communication that is happening to DTH at your home, that is direct to home, that is set-top box, communication which happens in IoT, communication which happens in your wireless sensor network, this will have model, a general model, which is shown here in this diagram. So what is going to change? Information source is going to change, encoding may be changed, modulator may be different, the type of channel will be different in different applications. Of course, when modulation is different, the modulator has to be different. Encoder corresponding to given encoder, there will be a decoder. And user. End user in mobile communication, you are end user, while however in wireless sensor network, in node is end user. End user may be a node, maybe a human, it may be a non-human, it may be a computing device, it may be a node, or it may be a server, it may be anything. So depending upon application, this model is quite relevant and useful at the physical layer of the communication system. So if I look into mobile communication, as I'm speaking, and the same thing is being received by you, so what are the important components? So this is what is a signal, that is analog signal. There is a transducer, that is a microphone, electrical signal. I call it as electrical, not electronic. Electrical signal is there. Then after there is a processor, which processes. My signal is not just sent as it is. There are some filters, there are some modulators, and then after it is given to transmitter. So what does transmitter consist of? It actually has a, either it is having high performance amplifiers and antenna. If it is a wired communication, antenna is not required. If it is a wireless communication, antenna will be required. So we will discuss that particular aspect as well. So what we are getting especially is electromagnetic waves. So these electromagnetic waves are being sent either through free space or through wired channel, and at the receiver we are basically getting the same signal to the user, and this is what the user is. So this is what the element of communication in general. So another important point is, if you look into this previous diagram, now the first part is the information source. So what is the information? What is the data? And what is the difference between information and data? And what are the different information source? Is something that we should know. So information, what is information? You see, suppose now what happens is in morning you read newspaper. So why do we read newspaper? Because we want to know something very new. If something is monotonous, if you're getting the same information from the newspaper, then you would not like to see the newspaper every morning. You will not have a curiosity to see the newspaper every morning. Curiosity won't be there. Similarly, in the news channels, if you see, you basically switch on to a news channel just to know what is happening new. Is there something new? So what is information? Information is something which is new. And what is new means it is useful to the humans, and that is information. So actually it is a processed data, a data which is in transcendable form, a data which can be inferred. Inferred means it can be, you can make some conclusion out of the data, that is the information. So again, it has some logical meaning. So if I put some ones and zero in front of you, then it is not information, and that actually is the data. So what is the data? Is a raw material. So if we look the same thing in a different aspect, I present ones and zero. Now what happens is how this my laptop is working, how my computer, how my mobile is working. They are working on ones and zeros, and that is a machine level language. So ones and zeros, if I show you, if I see myself, I'm not able to infer something because I don't know what this one is corresponding to, what this zero, what are the meaning of 1011. I don't know. So that is the data. And now if I convert that data into alphanumeric, I mean to say letters or words or numbers, then I will get something. For example, AMIT, Amit is there. A is if I encode A by 7 group of 7 bits, M by 7 bits, I by 7 bits, and T by 7 bits, and present that group to you, you won't be able to infer. However, when I convert back that 7 bits into AMIT, again you will get that information. Oh, that means that particular name. So that is difference between information and data, and this is what we are communicating. Either we are communicating information or we are communicating data. So you may ask, when most of time we have to communicate information because that is something which is important and important to the user end. No, there are some application in which we are communicating data. For example, in wireless sensor network, one node is communicating with the other node. So what is happening is that one node is, for example, you want to sense the presence of some animal in forest. So it is, you have a sensor. This is a proximity sensor is there. The proximity sensor is collecting the information of whether if someone comes in the proximity, it gives a pulse 1, else it gives pulse 0. So if nobody is there, a group of 0 pulses will be sent by that sensor. Otherwise, it will send 1 depending upon the presence of the animal. So that data which is sent is that 1010, and you are interested in 1010 only. You don't want to either encode or decode that 10. So that is data which is to be communicated and which is of important interest to you at the user end as well. So now another important is, what are the sources of information? As we discussed, there can be various sources of information. So one of the source of information is the test signals. So what are the test signals and why we want these test signals? Test signals are of not of much importance as far as practical communication is concerned. They have just put up just for testing the system, just testing the, I mean to the scenario, for maybe a theoretical analysis or maybe a practical analysis, but not of practical importance. So for example, your sine signal, your cosine, your square wave, these are the test signals that we use. They can be a source of information. Voice can be a source of information. Your video signal can be a source of information. Your seismic signal, the earth signal, can be a source of information. Your ECG, EEG can be a source of information. So that means you may be interested to send the data, these information from one place to other place in the form of data. So now there's something which is also called as the important communication resources. Now, you see, in our life, we have communication resource. We have important natural resource. So, for example, we call sun is a very important natural resource. Coal is an important natural resource. We must preserve these resources to the extent that is possible. Similarly, we say this different mines from where we are extracting the minerals are important resource. We should not extract that. So these there are important natural resources. However, in the similar way, in communication also there are important resources. That is, they need to be preserved to the extent that is possible. So what are the important resources? There are two major important resources around which communication engineer is supposed to work, around which major research problem basically revolves around these two resources. And that is bandwidth and other is power. So what is a bandwidth? Bandwidth is basically a range of frequency over which a communication engineer at the physical layer is supposed to work. And what is the power? Is the amount of the, the power you are supposed to transmit from one place to other place. So why bandwidth is important communication resource? Because it is very costly. And then you see, why something become very important? Because of scarcity. So if there is something in something which is available in the huge bulk, then it won't be very important. So if gold is available in less quantity, it will become very important. So its price will definitely hike. Similarly, bandwidth is not available in bulk. There is a a given range of frequency over which you are supposed to work. You means a communication engineer is supposed to work. So that particular range of frequency need to be utilized appropriately in such a manner that many of users can be connected within the same bandwidth, and that is why it is very important resource. Similarly, power is an important communication resource. Now, how power is important communication resource? For example, in mobile communication, what is happening is you have a mobile, and nowadays when we purchase a mobile, we see few features, and one of the important feature is we see what is the camera, pixel, how many pixels are there in a camera, what is the processor, and next important feature is what is the battery life, okay, and what is the type of operating system it is there. So one of the important parameters is the battery life, especially in the Android phones. So in Android phones, in the previous non-Android phones, the mobile phone used to run for maybe 4 to 5 days, depending upon your usage. However, in Android phones, this battery usage is maximum 2 days. So now we have 5,000 mAh of battery, we have 3,000 mAh of battery, and however, in non-Android phone, even very small mAh used to give very large backup. So what if I devise a technology, a communication engineer, a researcher devise a technology which is by which he or she is able to communicate the signal to a longer distance with the less power requirement? What if he or she basically devise that technology, then the same mobile which was supposed to run for 1 day will run for more than 1 day. The same in wireless sensor network, a node which was supposed to run for a week or for a month or for a year will run for more than a week or more than a day, month or years. So that is the importance. Even in satellite communication, one of the important constraint is your power. So because you have to transmit power, a large amount of power from one place to other place. So from that viewpoint, these two are very, very important communication resource, and especially in wireless communication, So as a communication engineer, we should devise a technology which will improve quality of service without compromising, without requiring extra bandwidth or extra power at the physical layer. This is the one of the important problem for a communication engineer, for a network engineer, not a network exactly, for a communication engineer at the physical layer. So till now, if you have any doubt, then we can discuss. Any of you, if you have any doubt? If someone wants to ask something, then we can discuss. Otherwise, we can start further. There is one concern that Priyanka SM, she is not able to observe this slide. Okay, 1 minute. Priyanka ma'am, are you able to see this slide?
Yes, sir.
Okay. So I hope whatever we have discussed till now is okay, and we can go proceed further. If you have any doubt, you can ask. Otherwise, we will proceed further. Okay. So now another important aspect is now we say now what is happening nowadays is we say digitization. Digital India is one of the important terminology that our Prime Minister uses in his frequent speeches. So there's something which is called as a digital communication, and your Digital India term is actually derived from that particular thing. We'll discuss that. So the communication that used to be there in 70s, 1970s is used to be analog communication, which is said to be a 1G communication. So frequency modulation used to be the modulation scheme for communicating wirelessly. Then after this digital communication, we developed a digital communication, and we saw the different advantages that digital communication is offering, and we saw that to how long we will be able to go with digital communication, and then we basically converted that analog, whole infrastructure of analog was shifted into digital domain. So today also analog communication exists and has its importance. And now we are shifting from analog to digital. And why we are shifting? Why we want to shift in digital domain? Are there any minus also of digital communication that we can see in this? And what are the research direction for a communication engineer in this particular aspect? So first of all, analog communication. So communication is divided. You can classify. You can classify communication in various ways, but one of the way on which you can classify is the analog communication and digital communication. So you will say, I am using an analog communication system and you are using a digital communication system. So question arises, what is analog and what is digital into this? So the important thing is that if you ask me what is difference between these two, then the only difference between these two is the type of source that is used. For example, if I am speaking that my voice is converted into electrical form, that electrical signal is analog in nature. Now, why it is analog, and what is analog? A signal which is continuous in time and continuous in amplitude is called as analog signal. So that particular signal, if I draw the voice signal, if you see the voice signal in CRO, if you see the voice signal in any of the, if you Google that voice signal image, then you will see very random pattern. So it may acquire any amplitude at any instant of time. That is why it is continuous in time and continuous in the amplitude. So a signal, a communication in which my input is analog and my output is also analog is analog communication system. And because of these, my requirement, that is my input is requirement is different, and I want also in analog form, and in between I'm also using analog subsystems for its processing. That makes something which is called as an analog communication system. Similarly, there are applications. Now you may ask, I mean to say, what are the application area of analog communication? Are we using still analog? Because nowadays we are We are talking about digital India and digital devices and systems. So yes, analog system exists. For example, your nowadays you have your FM and AM transmission. This is analog modulation schemes and analog communication. So, however, your mobile communication, your internet, and your IoT, your wireless sensor network, and the defense application, most of defense application, they are working on digital communication system. So, what is the change between analog communication system and digital communication system? The major change lies in the information source. The information source in digital communication is supposed to be digital in nature. In analog, it is supposed to be analog in nature. So, what if source is not in digital form? Because most of the source which exist in the nature are not digital. My voice is not digital. My image is not digital. Okay, if I sense that image, the signal, electrical signal that will come out of that image or video is not digital, it is analog. So most of signals that exist in the nature are analog. But what then, how digital communication will take place? So in that case, I have to convert that analog into digital form using a source encoding technique. Then after, I have to use something which is called as channel encoding technique. Then I have to modulate. So these two things are not there in analog communication, and this is there in analog communication also, and that is the analog modulator. This is a digital modulator, there is analog modulator. Channel is common in both of these, whether it is analog or digital, and then it is reverse of your transmitter. That is, this is a modulator, this is a demodulator, your channel decoder, channel source decoder, and then you have the output. So what is there that makes digital communication different from analog communication is your source encoder and channel encoder, the requirement of source encoder and channel encoder. So what is source encoder? Source encoder is a technique by which you are converting analog into digital form. So you can say a source encoder is your A to D converter. Is actually not only it is converting, it is efficiently converting. So again, there are two type of, there can be classified, source encoder can be classified as pulse chord modulation. For example, you might have heard of this thing. PCM we used to use in ISDN network previously in communication systems. So in wired communication, we used to have ISDN, integrated service digital networks. So in which we had the maximum data rate of 64 kbps. So that is your, I mean to say, one of the A to D conversion technique, PCM. Another technique is your vocoders. Vocoders are very optimized encoders. I mean to say, they basically, sometimes you are very interested in storing the large amount of data rather than quality. For example, in aeroplane communication, you have black box. Okay. So in black box, your priority won't be to store high definition data, high definition voice. Rather, your priority would be to store a voice which is perceivable, and not only it is perceivable, but it can, you should be able to store large amount. You should be able to record the data for long interval of time, so that maximum decoding can be stored, saved, and retrieved in case of any emergency. So that is where your encoder find a place. You see, a PCM requires 64 kbps, a general PCM, pulse chord modulation. So that is, if my voice is input to PCM, the output data rate is going to be 64 kbps. However, in vocoders, that is a voice coder. Vocoder stands for voice coders. This source coding becomes so optimized that you can work even for 2.8 kbps. So you can see 64 kbps data is converted into 2.8 kbps. So if you want to use this particular, I mean to say, communication for recording, if you want to use A to D converter for recording, you should not use this 64 kbps, that is PCM. Rather, you should use vocoders that is working at either 2.8 kbps or even 1.6 to 8 kbps as well. So that is the beauty of source coding. So it is not only converting analog into digital, but it is efficiently compressing that analog into digital form depending upon your application. Then you have something which is called as channel encoder. Channel encoder, this is the beauty of digital communication, which is not available in analog communication. So, suppose what is major challenge of of a communication engineer in communication system is your channel. Channel is a major challenge. So why channel is a challenge? In channel, non-linearity and distortions are the challenge. So what type of non-linearity and there will be a noise in the channel that may be internal to the channel, that may be external to the channel. A noise which is from within the system itself is called as the internal noise. A noise that comes out of the system is called as external noise. For example, I'm using laptop for communication, and my fan is also rotating. So fan is basically working on the electromagnetic field radiation. There is a, I mean to say, induction phenomena that is happening by which motor is running. So the field which is produced within the fan is not confined field. It is coming out of the fan also. So I'm also, we all are basically have so many electromagnetic field which is surrounded by us. So if that is so, that may interfere with my communication, that may interfere with the channel channel which I am using for communication right now. So that is external source of noise. Similarly, if my laptop is there, if my mobile is there, within mobile I am using various semiconductor devices. I'm using a chip. Within the chip there is a noise. They will generate noise by itself because of thermal. My signal which is transmitted will also get changed. My amplifier, my transistors, or my diode, the way they are supposed to work will not work. So the signal which is at the input of these amplifier or semiconductor device won't be same at the output. So that is the internal noise. So that is a major challenge. Now, how to counter this challenge is one of the research area as discussed earlier. So one of the way to counter the challenge is to design the receiver in such a manner that I should get better quality of service for given bandwidth and given power, or for the reduced bandwidth and reduced power. This is one of the area for communication engineer. The other area is what I want is I don't want to sacrifice band. I don't want to sacrifice power. Power is very important communication resource. For example, in some of the applications. In that case, I would like to sacrifice bandwidth, and this is where channel encoding is. What is channel encoding? Channel encoding means you are introducing some extra bits along with the information bits, and these extra bits, these are also called as redundant bits. These are also called as guard bits. They will guard the main information signal, main information bits from the effect of noise and distortion. For example, Hamming code is the basic and layman language channel encoding scheme. You might have seen this Hamming code in computer science, in IT, maybe in electronics, it is extensively used. So channel coding. So now we have cyclic code, we have BCH code, we have convolutional code, we have combination of block code and convolutional code, which we call it as a concatenated codes. So these are basically forms important channel coding and being used in mobile communication, satellite communication, in IoT application. Depending on, again, it depends on application. In some of the application, it may not be required. In some of the application, the amount of noise may be so less that I would not like to sacrifice bandwidth for power. So that is where the channel encoding is very, very useful. By introducing some extra bit, I am able to secure my data. That is so beautiful. So this is the difference between analog and digital. So these two blocks are creating the difference between analog and digital. The source encoder, requirement of source encoder, and channel encoder. Now, so this is what we were talking about. There is an analog, I mean to say signal. There is a digital signal that we discussed. So this one is your analog. This one is your digital. This is continuous in time as well as continuous in the amplitude. What is the meaning of continuous in amplitude? Continuous in amplitude means it has infinite varieties in the amplitude. That is the meaning of continuity in amplitude. While if you see this digital signal, it is this particular bit exists for only this much interval of the time, and that its amplitude is also limited. Okay, it may be a V volt, it may be V dash volt, it may be E volt, but it is fixed. Either it will be V volt or 0, and that is where So it is discrete in time and discrete in amplitude, and that is why this is called as a digital signal. So now we were discussing analog. We have seen what is analog communication, what is digital communication. The important, why digital? Why digital? What is difference between these two? Okay, so it is important to see. So as we have seen, we are shifting from analog communication to digital communication. There are inherent reason why we are doing this. We'll discuss that. So first of all, this in analog communication, the signal is analog in nature, while in digital communication, we are supposed to send digital pulses. Again, digital pulses, if they do not exist, I must take analog and convert that into digital. Another important thing is that I'm using modulation, that is amplitude, frequency, or phase variation, while in digital communication, amplitude, frequency, and phase is also used, but in different way. So I have something which is called as analog modulation scheme used in analog communication. So your amplitude modulation, your frequency modulation, your phase modulation, these are analog modulation schemes. Now, if you come to digital, you have what is called as your pulse power modulation. You have your amplitude shifting, your frequency shifting, your phase shifting, your quadrature amplitude modulation, your quadrature phase shifting, and so on. So these are the modulation schemes we use in digital communication. But the waveform used for this modulation scheme in both the cases is analog. Next important difference is noise immunity. Noise immunity of AM is very, very poor, while it is excellent in digital. This is one of the parameter over which digital communication wins over analog. This is one of the point over which we are phasing out analog communication over digital communication. Now you may ask why this is so. We'll discuss that. We'll discuss that later. But yes, as of now, you may think, you may, I mean to say, take it as it is that noise immunity. But before going further, what actually is a noise immunity? You see, as we have nowadays immunity, body immunity is playing very vital role in COVID-19. So what is happening is we are saying that virus is there in everyone's body, because the now unlock 4.0 has come, unlock 5.0 is about to come. So we cannot assume that virus has not entered into my body, that COVID-19 virus has not entered. I cannot assume this. If I assume, my assumption may be wrong assumption. But even if it has entered, I am not having the symptom because I have good immunity. So it is a play of the immunity. If my body immunity is strong enough that it is defeating the virus, then I am immune system. I am immune to that COVID-19. Otherwise, I am less immune or more immune. Similarly, in analog and digital communication, there is a concept of immunity. So what is immunity? What is the meaning of immunity in communication system? Suppose I am sending a signal and noise enters and it distorts the signal. So what if a same noise I am able to, if same noise is basically causing a lot of damage, then in analog communication as compared to in digital, then I will say digital is more noise immune to analog communication. But why it causes less destruction in digital, why it causes more destruction in analog, that we have to see, that we will discuss. Another is we use something which is called as a repeater. Now communication is happening. Now I am right now in UP, and one of the district in UP is a MIET district. So you people may be in different places. So communication which is happening is a long distance communication. So this communication is not happening in a one hop. It is not happening that it is happening just between two stations. No, there will be a different, I mean to say, various MSCs involved. There may be different BSCs involved. There may be different repeaters involved in between. And that is where analog communication loses, and that is where digital communication wins. That is, we are using regenerative repeater in digital communication, while we are using simply repeater in analog communication. Repeater doesn't reduces the noise. Analog repeater doesn't reduces the noise, rather they introduces their own noise, and that is why it causes performance to go down, and I'm not able to transmit for a long distance in analog communication. However, in digital communication, I am using something which is called as a regenerative repeater. Regenerative, the term regenerative means I am generating that signal again. So the signal, which is a basically a, you can consider this as a square signal, it gets distorted. Then after you are refreshing and you are again generating after some distance that same refresh signal by removing the effect of noise, and that is where so after certain interval I am refreshing. After certain interval I am refreshing. Maybe after 10 kilometers, maybe after 5 kilometers, depending upon what type of channel I am using, depending upon from where my channel is going. For example, if my channel is going through industrial area, through which there are so many electromagnetic radiation are there, so definitely amount of noise will be more, the amount of distance to which the signal can be transmitted will be very less. So in regenerative repeater, I'm able to remove the effect of noise and send it again, and that is where digital communication have a strong point, and it wins over analog communication. Coding is possible in digital communication, while it is not possible in analog communication. This is one of the important aspects, as we have seen in the last slide. We have source coder, we have channel coder. So channel code, source coding is the requirement, while channel coding is one of the advantage that one of the I mean to say significance that we are leveraging in digital communication. So that is, if I want to reduce the effect of noise by using channel coding, I cannot do that in analog, while it is possible in digital communication. Next, there is something where analog communication wins over digital, and this is where is the bandwidth requirement. The bandwidth requirement in analog communication is very low as compared to digital. This is where the digital communication fare low as compared to analog. So as I said, as we discussed that bandwidth is one of the important communication resource. It is to be preserved to the extent that is possible. So now you may ask, when bandwidth is important communication resource, then why we are switching to digital? Why we are not still continuing with analog? The reason is that the amount of advantages that digital communication is offering, except this particular bandwidth requirement, is so high that we are ready to accept this particular disadvantage of digital communication. We are ready to accept one more disadvantage of digital communication, that is analog to digital and digital to analog conversion. So in analog communication, you need not to convert in digital form, while in digital you need to convert. There is no other way. You have to convert analog into digital and then transmit. At the receiver, you need to convert digital to analog because you want the information in the same form. So these are the two important disadvantages of digital communication. However, you are ready to accept this disadvantage. Why you are ready to accept this disadvantage? Because digital communication is giving you advantage in so different forms, which are far higher, which is giving you far benefit as compared to this. This is something like this, that in your department there is one faculty. He has some problem, but he has various strengths, but one or two weaknesses. Then you tend to ignore weaknesses over the important strengths. This is where digital communication is winning. One of the important further distinction between analog and digital communication is your type of multiplexing. Multiplexing is one of the important method by which you can increase the efficacy of communication system. And this is where frequency division multiplexing, and we are using time division multiplexing in digital communication. Then we have something which is called as a secure communication. So you see, communication in some of the application has to be very secure, irrespective of bandwidth requirement, irrespective of power requirement. So for example, in defense application, if someone says that your communication is not secure, then you won't adapt that communication, because whole play in defense is of communication. So you will lose the war if communication fails. So in that respect, even if you have to chunk more power, even if you have to chunk more bandwidth, then defense people would like to have a technology which may require many times bandwidth, many times more power, but it has to be secure. It is of primordial of paramount importance to them as compared to your power and bandwidth requirement. So that is where the digital communication plays very vital role. In digital communication, you have coding technique, and this is where the subject of computer science starts. That is encryption. This is one of the important science in computer science engineering and IT for IT professionals. How to encrypt the data more securely with the less number of bits, with the less complexity, so that nobody should be able to capture or decode the data within the channel. And that is where digital communication offers this facility. Analog communication do not offer this facility. And as we discussed, the type of modulation schemes, you have AM, FM, PALM, PWM, pulse width, that is pulse width modulation. While in digital, you have PCM, delta modulation, adaptive delta modulation, differential pulse code modulation, amplitude shifting, frequency shifting, phase shifting, quadrature amplitude modulation, quadrature phase shifting. These are the different modulation schemes in digital communication. So this is the difference between analog and digital. If someone asks you, then as a communication engineer, we should know, as a network engineer, we should know, because fundamental to every network, wireless or wired network, is the communication system. So now the question arises, we were discussing why digital. So before entering into this, I'd like to ask, are there any doubts till now in the discussion till now? So first of all, let me check. Okay, I have some question. What is QoS? QoS stands for quality of service. Now, what is quality of service? You see, I am speaking something. So my voice should reach to you people in the similar way I'm talking. That is, there should not be much delay. There should not be much of the interference from the channel. Sometimes you see the background noise, and it should be perceivable. You should be able to record in the similar way. I mean to say, if you compare, for example, if you compare landline phones and wireless phones, then and I assume that your channel in the landline phone is working very well, then in that case, your quality of the voice that you will hear in your landline phone will be very far better as compared to the quality of the voice that you hear in mobile phones. Sometimes you have to press the phones against the ears if you are not using your earphone. You have to press so hard to your ear that if it is a long communication, sometimes it happens that communication becomes long communication, maybe for 30 minutes or 45 to 1 hour, then it becomes highly uncomfortable in mobile communication. Why, on the other hand, if it is wired communication and landline phone, and if the quality of the channel is okay, is good, then you won't feel that particular stress while talking in the, I mean to say, over telephone, over wired channel. And that is where the difference, the quality of service lies. Ultimately, I am getting a better quality in a telephone system as compared to this. But still, I am in a mobile communication. I want mobile communication because of one of the important difference, that is your convenience. I want mobility that is not there in wired communication. So this question is from Shri Dayal Sethji. So I hope this is clear. In case it is not clear, then you can ask me. Similarly, in quality of service, you have analog communication. There is something which is called as a figure of merit, is one of the important quality of service. While in digital communication, you have one of the important quality of service, which is called as your, I mean to say, bit error rate or packet error rate. So in digital communication, what is bit error rate? Suppose I have sent 1000 bits. So out of 1000 bits, 100 bits are in error, or 500 bits gets in error. So 500, that is number of bit in error, divided by how many bits transmitted, that is 1000. That is my bit error rate, and that is one of the quality of service parameter of digital communication. So 0.5. So communication engineer won't say that 500 and 1000. It will talk in terms of that number, that is 0.5. It will talk in terms of 0.3. It will talk in terms of 1 into 10 power minus 6. So in, for example, in PCM, the one of the important benchmark for PCM communication system is 1 into 10 power minus 6. Your bit error rate has to be 1 into 10 to the power minus 6. That means out of 10 lakh bits, one bit has to be in error. And then you will say your PCM system is working satisfactorily above the threshold. So this is one of the quality of service parameter. Similarly, in image transmission, if you are getting the same image, a high quality image, this is quality of service. So in analog communication, you have figure of merit as one of the important quality of service. What is figure of merit? How much noise is there at the input of the system and how much noise is there at the output of system, it defines your quality of service. So as I told you, noise can be internal to the system, noise can be external to the system. So suppose I have X dB of noise at the input of the system, and the system is itself generating some noise which is Y dB. dB stands for decibel. Then at the output, what I'm getting is I'm getting X plus Y dB. So this X plus Y dB is definitely, since Y is non-zero and Y is greater than zero. Okay, it is non-negative, and why the amount of noise cannot be negative, and noise is of course greater than 0 dB. So I mean to say it is it exists, it is contributing into the input noise. So in that case, my output noise, that is X plus Y dB, will be more than my input noise, that is X. Then X plus Y divide minus your X will be your figure of merit. In dB we subtract, in non-dB we divide. So that is your figure of merit. So figure of merit in that case exceeds, or it may exceed, or it may become less. So depending upon how much noise that system is introducing will define the quality of service of analog system. How much error that your digital system is introducing will define the quality of service of digital communication system. So this is the one of the quality of service parameter in physical layer communication. However, if you go in network layer, latency is one of the important quality of service parameter. Okay, in flow control at the upper layers, your quality of service parameter will change. Okay, and in the data link layer, for example, in the second layer, data link layer, your quality of service parameter will change. That is, in data link layer is mostly concerned with how much bits are to be added so that error-free communication is possible. So here quality of service parameter can be, because more bit I am introducing, it will add to more latency. So latency can be one of the important quality of service parameter at the data link as well as at the network layer. However, figure of merit and BER, or packet error rate, PER, are important quality of service parameter at the physical layer that communication engineer basically talks about. Okay, so okay, any other doubt? Any other query? Oh, sorry. So this is what we discussed, and bandwidth and power are important communication resource. The difference between these two. Now the question arises: why digital? Now we are talking about digital India. So why we are talking about digital India? Why our Prime Minister Mr. Narendra Modi always talk about digital India, digital connect? Even our IT minister talks about the same manner. So what is the meaning of digital connect? What is the meaning of digital India? So first thing is that now every device is getting digitized, it's getting digital. As I said, analog communication is a thing of the past. Now we have in hand, we have digital watch, which is communicating through Bluetooth to your mobile, to your laptop. You have washing machines, you have your ACs, you have your televisions, you have your D2H, whatever device you take nowadays, which is coming up to add up to your convenience today, that is digital devices. And why? What is something that makes it digital? The important aspect of digital is it has something which is called as an embedded system, and an embedded system is controlling the different aspects of that device, and that is basis of IoT. This is basis of wireless instant network, and this is basis of your even mobile is also a embedded system, because it has a processor which is supposed to work in a particular fashion. It is supposed to design. It has been designed and supposed to work in a particular fashion. So these are digital devices. That is why we are talking of digital connect. We are not talking of analog connect. So by default, communication is going to be digital. The one thing, okay. Second thing is, again, as we discussed, why digital? Why we are shifting to digital? Why we are converting? Why we are talking about digital? So as we discussed, one of the important thing is your better noise immunity as compared to analog communication system. So if you refer to this below figure, then you can see that on the x-axis we have propagation distance, and this is a distance one original pulse. You can see the original pulse is very sharp pulse. It is just a square wave, okay. And then after that particular square wave is transmitted to a distance 2, so some distortion has come. So you can see how the square wave is converted into a different wave. So, and this particular change is happening in terms of expansion. Expansion in the sense that you can see this width is limited. However, this width is very large. So I can say that this particular pulse is expanded as compared to this pulse. Then after I have transmitted this pulse to a long distance, and still more expansion has taken place. So not only there is expansion, the amplitude has gone down. You can see the change in amplitude from first pulse to second pulse, from second to third, and third to fourth. You can see not only it is expanding, it is changing shape, and but also its amplitude is going down. So there are two phenomena that is happening. One is its amplitude is changing. We call it as attenuation. So attenuation is something which basically is inherent in communication channel. This is inherent property of communication channel. So what is attenuation is like this: if you move from your offices to your home or home to offices, you feel, I mean to say, tired. You feel loss of energy, and that is attenuation. We can call it as attenuation. Similarly, when you are transmitting in wired communication, then your power is decreasing. When you're transmitting wireless communication, it is decreasing. And the fashion by which it is decreasing in wired and fashion by which it is decreasing in wireless is different fashion. They are different. For example, in wireless, it basically decreases to a more fastly as compared to wired communication. So that means the attenuation of power is more in wireless communication channel as compared to wired. So why it is more? Again, it will depend upon whether I am working in a urban area or I am working in a rural area. If I am working in a rural area where there is a field, attenuation is going to be low. So, and if I am in an urban area and less congested area, attenuation is going to be higher than what it used to be in a rural area. And if I am in a metropolitan city where congestion is very high, there's so many vehicles, so many buildings, then attenuation is going to be of the highest order. So my attenuation depends on the environment in which my communication is taking place. So ultimately what is happening is my pulse, this is a pulse which I am going to get at the receiver. But this is not my desired pulse. My desired pulse is this. This is my desired signal. So in digital communication, I'm concerned with ones and zeros. So what happens is if my one get converted into zero because of this change in shape. So because of that reason, it may happen that my data become erroneous, and data erroneous means bit error rate will increase. Increase in bit error rate means quality of service will go down. So if quality of service is low, definitely you will complain, and the company will not be able to hold the customers. So one of the important challenge for a communication engineer is to retain the same pulse at the transmitter as well as at the receiver. And this is where this, I mean to say, digital communication plays a vital role. So what does it do? In digital communication, we use in between something which is called as a regenerative repeaters. So, for example, at the fifth place, I'm using something which is called as a regenerative pulse repeater. So, this pulse is at the input of the repeater. What does it do? It will compare this pulse with the threshold. That threshold is decided by the engineer, communication engineer. It is decided based on the type of modulation scheme you are using. It is decided by the type of communication that is happening, whether it is a baseband or passband. So depending upon that, it will compare with the threshold. For example, if I compare this particular amplitude with the threshold, if that particular amplitude is above the threshold, I will say, yes, a pulse is to be generated, a positive pulse is to be generated. And if this particular amplitude is less than a threshold, I will say a negative pulse is to be generated. And finally, what I'm getting is a fresh pulse. So you can see distance 1 to distance 5. There was so much of distortion. There was so much of noise added. Not only distortion, noise added. But at the fifth place, I have countered all the noise. I have shed all the noise. And finally, what I get is a fresh pulse. And that is called as a regenerative pulse. And that is the beauty of digital communication. That is, I'm able to recover back my original pulse, and that is fresh pulse, and I'm able to shut off my effect of noise and distortion that was in between distance 1 and distance 5. This makes digital communication quite suitable for long distance communication, and that is why we are more interested in digital communication. That is why we are talking of digital communication, digital device, digital connect. This is one of the main important reasons. Okay. However, there are other reasons as well. Now, suppose this is the first explanation of the first, as well as I can say this is second also. So, better noise immunity is also one of the important reasons that that is there in digital communication. Why better noise immunity? There are two terms in communication. One is called as the estimation, other is called as the detection. So, what is difference between estimation and detection? So you see, suppose in radar engineering problem, radar is basically a communication system. So for that, we need to design a communication system. It will need some protocols also. And what happens is you have been given, or we have been given a task to know whether some radar has to know whether some object is present or no. Number one, if it is present, then what is the size of the object? Number three, whether it is a moving object or a stationary object. And number four, if it is moving object, then what is the velocity by which it is moving? There are four statements and someone asks you. There are four hypotheses that is put in front of you. Then what happens is, what you do is, the first problem, that is, you will send a pulse, and if there is some object, then pulse will strike to that object and it will come back to the receiver, and depending upon the amount of energy that is received by the signal receiver, you will decide whether this object is present or no. So that is called as the detection problem. That is, you are detecting the presence and absence of the target. Second, if it is present, you know you want to find out the size of the target. Now, what you will do is you will again send, I mean to say, signal, and from different positions, and at the receiver, with the with the help of different algorithm, you will try to recapture the image. You will try to reproduce the image of the object, and that is your estimation problem. You are estimating the size of the object. So one is, first is the detection, second is the estimation. The third problem is you want to see whether it is moving or running. So what you will do is, again you will send, and you will use something which is called as a Doppler shift. It's phenomena. What is Doppler shift? So once a pulse is tracking the object and object is stationary, then the pulse which is reflected back at the receiver, you will get the change in frequency will be minimal. The signal which is transmitted, that will have a particular frequency. The signal which is received, it will also have a particular frequency. The change in transmitted signal frequency and received signal frequency will be different. 10:30. कहाँ पे? ऑनलाइन मीटिंग 11 बजे आपकी ये तो मेरा है। अच्छा। ऐप के रिगार्डिंग नंबर में भी आया। ठीक। Okay. So what I was saying is I'm interested. So if the frequency of the transmitted and received signals are same, then what I will have is I will have same. I mean to say, if object is stationary, then I will have same frequency, and that is there is no Doppler shift. On the other hand, if object is moving, there will be a Doppler shift, and I will be able to know whether it is moving or it is stationary. And there is again a detection problem. And next, the last problem is I want to know this, the velocity by which it is moving, whether it is moving linearly or in a circular motion, and if it is linear or circular, what is the amount of what is the velocity? Then it has to find out. This is what is estimation problem. So in detection problem, in digital communication, since we are interested to know the presence and absence, that is why we are able to retrieve in more effective way as compared to the analog communication. So I think time is over. I think you all have to join your AICT inaugural session. So the rest of part we'll discuss. We'll start in the next session, that is starting at 12:30. Meanwhile, if you have any concern, we can address that. Any concern in the discussion that is held till now?
Thanks a lot, sir. Myself, Abhilash. Thanks a lot for your kind lecture and the information sharing. The second session will be started from 12:30 to 1:30. And now you are requested, all the participants are requested to please move to YouTube link, which I shared at the chat box. And it's a live streaming of the inaugural session by the AICTE chairman. So, thanks a lot.